Hey, what's going on, y'all? It's Sean, the owner and lead tutor of Math Swap Tutoring. And today I am going to talk about what a function is. And this is for calculus. But function is not just a calculus type of thing. It's algebra, really is what it is. But of course, with calculus, we're going to end up taking it a bit further. So let's talk about what in the world a function is. Okay. So give me a second here. Plug up my equipment and here we go. All right. So what is a function? Now, if you're in calculus, then you've already seen a function before. But of course, with calculus, well, you've seen this in algebra, but you're going to take this further with calculus. So in a nutshell, let's do this here. Say you have some machine. Now, we don't know exactly what this machine does, but everything that this machine does is inside of this box right here, if you will. Okay. So what you do is, for example, like an assembly line. So you take some kind of raw materials that you put into this. Let me draw that a little bit bigger so I can really illustrate this the way I want to. So you put some sort of raw materials into this machine. That's what we're going to call our input. And then out of the machine, you're going to get something. And we're going to call that our output. For example, the car that, you drive or your parents drive or whatever, it doesn't go in as a car. It goes in as, steel, plastic, glass, all the raw materials. It goes into that machine and then it comes out as a car. Okay. So this is really in a nutshell what a function is. Well, basically you have an input value into the function and then the output value, which depends on whatever you put into the machine. So this part right here, the machine is the function. You have an input and an output. Now, with a mathematical function like what we're talking about, and it's so cool. This is why I like math, because math really just kind of helps to illustrate life. So with well, let me not go there yet. So the main thing to kind of realize here is that with a function, the output depends on the input. Whatever you put in determines what you get out of the function. Okay, so say for example, and so you've seen this before. Say for example, you have f of x equals x squared. So this function of x, the function that's dependent on x, is equal to x squared. Okay, so in other words, the value of the function, the value of f of x, depends on whatever x is in here. Whatever you plug in for x determines the value of f of x. If you plug in 2 into this, the value of f of x is 2 squared, which is 4. You plug in 3 for x, the value of f of 3 is 3 squared, which is 9. You see what I'm saying? Another one that you may have not necessarily seen as a function is the formula for area. What is area dependent on? The input, which is your variable r, your radius. So whatever your radius is determines the area. You see, some would write this as a sub r equals pi radius squared. So area as a function of radius is equal to pi radius squared. It's not a function of pi. All pi is a constant, but your area is determined by the value of the radius. You see what I'm saying? Your area is dependent on the radius value. So you can see that this is really applicable in so many different kinds of things. Again, it's pretty cool. I'm like containing myself here. um, but anyhow, so let's kind of put some more definitions here so we can kind of build this thing up. So for every input value into the function, there's an output value. So for every input value, usually will be X, the output value is going to be F of X, or I'll say Y equals F of X, because F of X tends to be F of X is associated with what's typically the Y value. Okay. What else we want to put here? The input value is also known as an independent variable. Which kind of means it is what it is. It's just kind of like it doesn't depend on anything. It's just whatever is set to be. The output value is known as a dependent variable. Depending on what? Depending on whatever the input variable is, whatever X is. You see what I'm saying? Because again, whatever F of X is, it depends on the value of X. Okay. All right, good. Input, output, X, Y equals F of X. Independent variable, dependent variable. All right. Now, so the domain, some definitions here, is the set of all possible X values or all possible inputs. The range is the set of all possible Y values. And Y values, of course, are outputs. So hopefully you kind of see how straightforward this is. It's pretty straightforward. Okay, all right, so let's keep on going. Now, there are various ways that a function can be shown, okay? So here, but before sorry, I'm kind of getting ahead of myself here. All right, so let's look at this. Let's look at a graph of a function. Graphing a function is a way that you can represent it graphically, or you can say visually. All right, so let's say that on the y-axis, remember y is equal to f of x. This is the x-axis. See 1, 2, 2, 3, 4. Okay, all right. So let's say that you have something that looks kind of like this. It starts at 1, and then it comes down like that. Okay. All right, so we don't know the equation, the algebraic way of writing this right now, but we see that this is a function that we have here. All right, so anyhow, note this: f of x is the height of the graph at any point x. So for example, the value of f of x when x is equal to 0, which is right here at the origin, f of x is equal to 1. So we would say f of 0 is equal to 1. So we just plugged in a 0 for f of x. So f of 0 when x is equal to 0 is equal to 1. Okay. All right, let's keep on going. All right, so let's see. The domain of f of x, remember we just defined the domain as a set of all possible x values. So if you look here, remember this is the x-axis here. Here is our function. All the possible x values start from the beginning of that function to the end. So that means that x is only between 0 and then 4. X is equal to 0 all the way to x is equal to 4. So you would write that like this. So x is between 0 and 4. X is greater than or equal to 0, and it's less than or equal to 4. Quick note, if you note, I didn't write it like this. I didn't do like that. X is greater than 0 and less than 4. It has to include 0 because you see here, 0 is a point on that line. So that means X can be equal to 0. 4 is a point on this line. So that means that X can actually be equal to 4. Okay. All right. Okay, let's keep on going. Now let's talk about the range. The range of f of x is the set of all possible y values. Okay. So how high and how low does x go? I mean, how high and how low does y go? Okay, so the lowest y value is here when y is equal to 0. The highest y value is when y is equal to 2. So that means that the range is as follows. Y is between 0 and 2. Okay. And so make sure you look at that carefully to see that this is indeed the range. All right, good. So I just wanted to do that to illustrate a function graphically and help you to see the domain and the range and to see that f of x, how it's associated with x and how it is actually the same thing as y. All right, so let's clear that and let's talk a little bit more about how functions are represented. So functions can be represented one of 4 ways. You have verbally, and we've kind of been doing that, numerically, algebraically, and visually. Hold on a second. Okay. All right. We'll do this and we'll be done with this video. All right. So say, for example, we have some function that we're going to call s of t. S of t is the speed, I'm just making this up, of a car at time t. Okay, so we verbally kind of described this function. S of t, function S of t is the speed of a car at time t. So at any time t, the speed of the car is S of t, okay? Now, let's represent that numerically. So by using a chart, okay? And you've seen this kind of thing before. So say you have a chart and it gives you possible t values. Remember, in this case, this is the input value. You know, it might normally be x, but in this case, it's t for time. And let's say for t equals 1, S of t is 10. For t equals 2, S of t is 20. T equals 3, S of t is 30. T equals 4, S equals 40. Okay. All right. So that's a way of representing this numerically. Now, algebraically means what is the algebraic function? So in this case, and this is pretty easy to see, S of t is equal to 10t, because you see when t equals 1, S of t is t times 10. When t equals 2, S of t is t times 10 again. When t equals 3, S of t is 10 times t again, you see? So that's how I knew that S of t is 10t. I made this little perfect, I made this perfect little function to make it easy for me. So hopefully it's being illustrated well on your end. Now, visually is essentially graphically on a graph. So this would look something like this, a linear function. So you see when t was equal to 1, S of t is 10. T equals 2, S of t was 20. T equals 3, S of t was 30. And then I just leave it on from there because I kind of drew that kind of small. And so there is how your function looks visually or graphically, if you will. Okay. So this is just kind of like an intro to like what functions are. Again, you've seen this before. This is algebra, but this is preparing you to take this whole concept of a function a good bit further than we have. This is where it really kind of starts to get fun. And I promise you, I mean, this sounds kind of geeky or whatever, but you'll see what I mean. All right. So anyhow, thank you for watching this video. Make sure if you want to get more videos that demonstrate calculus concepts that you subscribe to this YouTube channel. If you're actually looking for tutoring, make sure you go to mathswaptutoring.com. Let me write these down. Make sure that you go to mathswaptutoring.com. You can also go ahead and schedule a free consultation at calendly.com/math. Swap tutoring. Or you can call 478-254-0515. Okay. All right. Again, thank you. And keep watching. Make sure you subscribe.